And that is how we work those. Let's move on. The next part of our notes here has us solving exponential equations. When we solve exponential and logarithmic equations, what we want to do in both cases is isolate. So as we look at solving exponential equations, we're going to start by isolating the exponential term on one side of the equation, if possible. And then we're going to convert it to logarithmic form and then solve the logarithm. So here, the exponential expression is written on one side, so we don't have to do anything fancy. Now, if we convert this to a log, this is how we solve this. We're going to convert. So if I did this conversion, it would be the log base 2 of 32 would equal the exponent, because logarithm always equals the exponent of 3x minus 7. Now, this we can do in our heads or on our calculator. This is just asking 2 to the what power equals 32. You probably figure out in your head and your fingers quicker than you can type it into your calculator. But this side of the equation just simply equals 5. Now we have this simple equation, which we'll solve by isolating my 3x term, adding our 7, and 3x equals 12. Divide by 3, and we'll get x is 4. Checking it on your calculator, you'd have 2 to the 12 minus 7, which is 2 to the 5th, equals 32, and it's correct. Let's check our steps again. So isolate the expression. It was isolated. Then we write the equation in logarithmic form, which we did, and then we solve the equation. In example 2, we have 100 times e to the 0.08t equals 2500. So here, again, we want to isolate the exponential term. This is our exponential term. So to isolate it, we're going to go ahead and divide by that 100, which is multiplying by the e. This will give us e to the 0.08t equals 25. Now we'll convert. Since we have log base e, that's the natural log of 25, would equal the 0.08 t. So solving this, we divide by 0.08, and we get t equals natural log of 25 divided by 0.08, which this would be considered the exact answer. If we do this on our calculator, pause and do that, we get 40.236. Now this is considered our approximate answer, and this is considered our exact answer, because you can take this and round to any decimal place value you want. And this, of course, we approximated to 3 decimal places. Looking at problem number 3, we have a bit of a situation. Here, I cannot, well, I do have each exponential expression isolated, but converting it to just one log is not going to work out that well. So what we do is we apply a log to both sides. Now you can apply the common log, you can apply the natural log, or you can apply the log of one of these bases. Let's go ahead and apply the common log for now. Since these are one-to-one functions, we can apply a log to both sides. So I'm going to say the log of 4 to the x plus 3, oops, kind of like that, would equal the log of 3 to the negative x. Now, we learned above that we can use the exponential rule and take this x plus 3 out front. This is our power rule. So we have x plus 3 times the log of 4. And here we have a negative x times the log of 3. Common log of 3, I should say. What we want to do now is get our x terms on one side of the equation. So what we must do first is distribute this log to both terms in the parentheses here. So we'll have x times the log, common log of 4, And we'll have 3 times the common log of 4. And that would equal a negative x times the common log of 3. Okay, we're getting there. Now, in order to solve for x, I have an x term here and an x term here. If I'm going to go ahead and add this x term to that side because I want them to be on the same sides of the equation. So I'm going to add x log 3 to both sides. That'll give me 0 on the right side of my equation. So what I'll have on the left side of my equation, I'll write over here, is x common log of 4 plus x common log of 3 equals, oops, I'm also going to move this to the other side by subtracting it. So I'm going to subtract the 3 log 4. That'll get rid of it over here and move it to this side. So we're solving a simple equation. It just doesn't look simple because we're writing the word log in there. Now, in order to solve for x, we factor in x out of both of these terms. And we'll have log 4 plus log 3 left. Common log of 4 plus the common log of 3. So we factor that x out. To solve this, we'll divide by this here to solve for x. So we're dividing by the common log of 4 plus the common log of 3 on both sides of the equation. You can't cancel these because this isn't being multiplied. Now, this is what we call the exact answer. So we're going to say x equals a negative 3 log 4 divided by log 4 plus log 3. That's the exact answer. The approximate answer, punch that into our calculator using the parentheses. So our approximate answer becomes x equals 1.674. All right, now solving for exponential equations here, or excuse me, logarithmic equations is very similar. Again, we isolate. We isolate the logarithmic term, then we convert, then we solve. So in example 4, my logarithmic expression is isolated, so I'm going to convert it to an exponential form. This is base e, so this would be e to the 8th equals x, and we are done. That is our exact form of the answer. We want to get an approximate form. We punch it into our calculator, and we get x is about 2,980.96. I know I'm rounding to 2 decimal places here, and above I rounded to 3. You just want to look at what the derivative may be asking you to use 2 or 3 decimal places. Anyway, let's look at example 5. In example 5, we want to isolate the logarithmic term on one side, and it says, first, you may need to combine logarithmic terms. So in example 5, we have love. That should say log. I think autocorrect got me there. So we have log x plus log x plus 3 equals 1. This is a plus, so we're going to use our product rule and write this as 1 log of x, common log of x times x plus 3. Using that product rule from above equals 1. Now we've got it as 1 logarithmic expression, so we write it in exponential form. This common log, of course, means log base 10. So what this means is 10 to the first power would equal x times x plus 3. We have to solve this as a quadratic. So we have 10 equals x squared plus 3x. To solve this, we move the 10 over by subtracting, and we'll have 0 equals x squared plus 3x minus 10. To solve this, you can either use the quadratic formula, of course, or we can factor it. If we factor it, we get x to plus 5 and x minus 2. Solving this, we'd say, since these two are multiplying and giving us 0, then either the x plus 5 must equal 0, or the x minus 2 must equal 0. In which case, subtracting 5, we get x equals -5, or adding 2, we get x equals 2. Checking our answer, if we plugged in a 2 or a 5 here, if I plug in a -5 for x, I would have a negative argument here. So I know right off the bat, without even checking, that that answer doesn't work. If I plug in a 2, I'd have the log base 10 of 2 plus the log base 10 of 5 equals 1. Using our product rule, we would understand that this is the log base 10 of 10 equals 1, so it checks out, and we know that x equals 2 is a solution. On example 6, it says log base 3 of 2x minus 1 minus log base 3 of x minus 4 equals 2. Looks like we're going to have to combine these logs together. And since it's subtraction here, that means the quotient rule. So we're going to write the log base 3 of 2x minus 1 over x minus 4 equals 2. Now that we have this written as one log, we can convert it to an exponential form, which would say 3 squared would equal 2 times x minus 1 over x minus 4. Now here, let's go ahead and write that 3 squared is 9. When we solve this, we want to get rid of our denominator in the fraction. So what we're going to do is multiply both sides by the common denominator nicely. We multiply the right side and the left side of this equation by x minus 4. We're going to get rid of that fraction, and we'll have 9x minus 36 here would equal the 2x minus 1. All right. So here it's a simple equation to solve. 9x minus 36 equals 2x minus 1. Move our 2x over by subtraction. And get 7x minus 36 equal a -1. Then we'll add our 36, and we'll get 7x equals 35. Solving this, we'll divide by 7 and get x equals 5. Then we can check the answer by substituting it into the function. I give myself a little room here to do that. If we substitute it in, we'll have the log base 3. Now, if my answer is 5, this would be 10 minus 1. So the log base 3 of 9. And here, if I put in 5, I'd have 5 minus 4 of 1. So the log base 3 of 1 should equal 2. Well, we know this, the log base 3 of 9, that's 2, because 3 squared is 9. The log base 3 of 1 is 0. And 2 minus 0 does indeed equal 2, so it checks. And x equals 5 is our solution. So thanks for watching. I hope those steps will help you as you go through and work on exponential and logarithmic equations.